How's it going, everyone? Welcome back. Glad to be back working on this. I've been excited to work on this all day and to get into the digital side of this power supply. So, I had one quick announcement. I don't think I can remember now what it was. Uh, so the LED or the NeoPixel sign project. I have the parts, except for the circuit board itself. That is on its way. It came over the ocean from China last night, so it's in the United States now, so hopefully it'll be here soon. But it's still taking FedEx a little bit of time to get it here. But yeah, I'm hopefully in a couple more days I'll have that. So maybe Tuesday we can look at building it and starting to work on it or program it. So that'll be kind of cool, and then that'll be taking a break from this project. I don't know if I should do that or if I should like finish out the schematic and layout for this board and then program that one while I'm ordering this one. That might make more sense, actually. Yeah, I don't know. We'll see, but uh, anyways, just so you all know, it's still going on. It's still coming, and hopefully we'll be here soon. All right, well, let's get to work. I am going to turn the music back on, and just let me know if you have any questions or thoughts, or let me know how your day was. All right, let's see here. So where were we? Oh, we were still finishing out this. We still need to do the voltage divider on the inverter here, and then I think we needed one more capacitor as well. All right, so let's see. I pulled up this regulator again, but I gotta find the data sheet. Here we go. All right, let's find the example. So these resistor values we are definitely going to have to change, but we can probably still use the same capacitor value. So 0.47 microfarads. So let's find that next, because the resistor will be the one custom thing. All right, capacitors. I think a ceramic will work for this one. I think that's what it wants for this one. 680. Yeah, this will definitely be a ceramic one. Okay. So in stock, active. .47 microfarads. Here we go. And then hopefully we can get this in 0805. And we want cut tape. Some of these are kind of pricey. Well, the Samsung ones are cheap. Jeez. What is this going on? I might have to pay for. Well, I guess they don't cost any different for the higher voltages, except 50 volts cost more. Yeah, I'll probably get this one just cause. All right, let's see if we can find this or another one that is already made here. That one is not. 25 volts is probably also acceptable. Okay. This one's already made. We will place it. Two, three, four. All right. Turn off these long names. All right. Also, if you stop by to watch today's stream, make sure you say hello. I'd like to know who's watching. All right. Which one does this go over? So this goes between the output and the inversion. So I think what we'll have to do is we'll have to run a wire out for each one of these. All right, so if I just drop that there, that one there, and that one there. All right. This is between inverted and out. Okay, just trying to make sure. The orientation should not matter on this. Oops. Okay. Now the divider. Man, this is going to be a lot of components, too. I have a feeling this one's going to be kind of expensive. I'm going to have no money to do anything. All right. So for the divider, are the caps to filter the power supply input? Both, actually. The ones in this first one are electrolytic can capacitors, the cylindrical ones. Those will have a heavy filter, and then these smaller ones are ceramics. This next row of capacitors are ceramics, and those will be right up against the voltage regulator, so they'll do some smoothing as well right on the input pin. Same on the output. This first row here are these big can caps, and then this one is to help with the noise with the inversion. So it because this is how it determines the divider between this line, and the ground is what determines the output voltage, and so that's to help with that ripple and smooth it out. And then on the AC side coming out, I've also got two effectively super caps coming out of this. I'm only planning on populating one at the moment, but the second one's there just in case, and that'll smooth out the output from this bridge rectifier. So yes, They're to filter the power supply input, the power supply output, and the ripple from what decides the voltage and everything. Although you did just remind me, I think I need to put a couple of like 1 mega ohm resistors between the power and the ground, because when this thing turns off, it's gonna have so much charge stored in it. It's just gonna be sitting around. Okay. The voltage divider. So the formula for this is pretty straightforward. Here it is. So V out equals 1 volt times 1 plus R1 divided by R2. And resistors selected need to be less than 10K, otherwise it won't allow enough current to flow between them to actually put the voltage where you want it. So that being said, we probably need to figure out what our max is. I'm going to duplicate this page so I can keep multiple items open here. All right, here we go. So R1, R2. And then our formula. I'm going to need a calculator. Okay, so R1 divided by R2. I guess I need to either pick values or... Well, let's say our max, right? Our max is 24 volts. That's V out. So 24 minus 1. I'm just solving for the other side of the equation. 23. Oh, that's multiplication. I did that wrong. Sorry. Hold on. 24. It'd be divided by 1. I wonder why that's in. And then subtract 1. All right, so the ratio of R1 to R2 needs to be 23. So R1 divided by R2 needs to be 23. So if the max R1 can be is like 10K, 10K divided by what gives us 23. So that's 10 divided by 23. Or 10K divided by 23. $434.7 ohms. So this is 10K, and this is 434.7 ohms. Then you'll get 24 volts out of it. All right, so I guess we got to go a little lower than that. I was thinking about using... the other day I decided I think that with 330s were like the minimum that we could probably use and be okay. I guess that was from a 10 milliamp standpoint. But this is at a random voltage anyway. So let's get something around 400, I guess. And put that as, so get something around 400, put that as R2, and then R1 will be the adjustable. And I'll get an SPI controlled resistor for that one. All right, so in stock, active, and then let's go 0805. All right, now let's see what we got. We want something around 400. Probably a common value, though. Maybe 390. Yeah, 390 would probably be good. I don't know how much power it needs to dissipate. They don't really give me an answer for that. Just select resistors less than 10K. I don't think you should have a lot of current flowing through them. All right. Let's get something that we can order in individuals. And whatever has a lot in stock. How about this one? Yes. It's rare that they're made and ready to go. All right, 1, 2, 3, 4. All right, and then that one, you can't have too many capacitors, I always say. You say that now, but just so we're clear on where I've gone completely wrong with that, this particular capacitor, C1, is a 15,000 microfarads, so it's a 15 millifarad capacitor, which is huge. And if we look at the PCB, give it a sec to open. Wait for it. There they are. These two red blobs, these red cylinders, these are our capacitor, our super caps. You know, compared to here's a normal can capacitor off to the side over here, and there's this giant red thing. The reason these are red is because they violate a height restriction on this board, or on the in this system. All these components do, which I've never encountered before, but that's really funny. So yeah, there they are. I've seen bigger. Well, yes, I'm sure if you were doing something with, you know, power grid grade transformers and or like rail guns or you know something insane like that, but for something like this, that's kind of excessive. Basically, I'm able to unplug this thing from the wall, and it's gonna like run for a long time, just off those caps. All right, so these are the the small resistors, and they go where? Grounded inverted. Okay, grounded inversion. So each one of these needs to turn. Oh, clicked on the wrong thing. And then we'll bring that down here. Drop that right there. All right, just gotta do that for all of them. Bear with me here. All right, there we go. Now you've got me curious. I've been... Hold on. What's the biggest one I can buy just off DigiKey right now? 2.2 farads. Is that in stock? You can buy them. Wow. $300. It's 2.2 farads. What's the dimensions? Diameter is 4 inches wide. And it's 10 inches tall. Nice. All right. What is it for? What's an adjustable resistor? Not a potentiometer where you like split in between the middle, but the one that's just... Is it a potentiometer? Maybe it is. I guess it is a potentiometer. All right, so we need to figure out, we know that our max is probably gonna be around 10K. We need to figure out what our minimum is. So, is that formula here? So R1 is our small one at 390. The minimum voltage of this thing is 1 volt, I believe. So how do we get 1? Times 1 plus R1 divided by R2. Hold on. I thought the minimum of this thing was 1. One to 0.8 times Vn. So how do you get 1? The way this formula works out, it doesn't seem to make any sense. Oh, I guess you effectively bring R1 down to 0 to nothing, and then that would do it. Okay. But we're not doing that here. Did I put that small one in the right place? R2 is the... I'm thinking of this wrong. Okay, yeah. So you connect the inversion to the output basically directly, or with a really tiny resistor. And that would effectively make it, bring it down to 1 volt. So really we can use any size between... Okay, that makes sense. So we can use anything between 0 and 10K. So we need a potentiometer that goes 0 to 10K. Or what is it, digital potentiometer? Digital potentiometers. Ah, 4-channel potentiometer. That sounds great, except it's $116. We probably want something linear too, just to make it easier. All right, in stock, active. I'm a big fan of using SPI, just because of how straightforward it is, so. And then we want a 10K as max, right? Wow, some of these are kind of expensive. These would be hard to mount too. Let's see if we can find a through-hole component that does this. That doesn't break the bank. Okay. I just want everyone to know that I just now got the notification from Twitch that I started my stream. So 30 minutes later. Alright, do some of these have multiple channels? Because that would be incredibly useful if we only had to get like a couple of them. Yeah, we can get up to... Okay, we can get one with 2 circuits or one with 1. Let's try for a 2 circuit. Less parts we gotta buy, I guess. I think we'll probably end up having to make whatever the footprint is for these. All right, let's see what we got. I also need to know like what the voltage thing, like what the max is. All right, so it's this one, the dual potentiometer. What is the cost differential? You know, I honestly don't know. Let's see, let's go back. 3, looks like the cheapest ones are about $1.58, $1.21. It's the absolute cheapest, and then if I take away the number of circuits, filter. Looks like you can get, instead of like $1.20, like 30 cents off if you buy one. So, no, it's cheaper if you buy a 2 circuit. Definitely. If you, because 2 of these would be 180 cents, so $1.80, and I could get it for $1.20, a 2 circuit chip. That is a great, but yeah, good idea to look into that. Yeah, $1.18. What I don't know is like, I need to be able to put a lot of voltage on the pins, or on the resistance. It needs to be able to handle like up to 24 volts. So high voltage tolerant digital inputs up to 12.5 volts. See, that's not high enough. Let me double check. Resistor terminal input. But I don't know if that's the same thing. Pin voltage range. All right, let's see. What's the pin out here? Which ones am I interested in? P1B, P1W, P1A, POB, POW, POA. Okay. So I don't really care about the other pins. So you can supply it with 3.3 volts. Sure. 450 microamps to 1 milliamp for serial interface active. That's fine. Eight bit. That's pretty good. resistance will be plus or minus 20%. That's quite a big variance. One of the things I'm going to do though is put a ADC on the outputs, so hopefully I can the chip will be able to see what it's at and adjust the resistance accordingly. So max current through it is 2.5 milliamps. Okay. That should be okay. Resistor terminal input voltage range, only up to VDD. What? Polarity with respect to each other is not restricted. What does that mean? I think that means that with respect to each other, like it's fine to do whatever voltage, but if you go above VDD, I don't know if it causes issues. Oh, that's disappointing. Oh, excuse me. It seems strange though that it'd be so low. I would think something like this would have to allow for a lot higher than that. Well, all right. Well, I guess I gotta find something else then. That'll give me a little more power, but I don't know if there is anything. Four two five one, 4241, 4261. What is this one? Okay, so they all use the same data sheet. So what is the difference between them? Ugh. Two is a rheostat, one is a potentiometer. .7 to 5.5 volts operating range. 1.8 to 5.5. Interesting. So like these two rows, right? The 4241 and then the 4261. I don't understand what's the difference between them. Huh. All right. Well, it looks like here then they all are of that type. Oh, excuse me. Nothing better there. So this is a $6 part with no data sheet, evidently. Oh, there it is. Oh, it's you can get it as a 4-channel. Interesting. Current. Oh, excuse me. It's got all the commands here. This particular one is a 4-channel, so I do like that part. I just wish I knew what the max voltage was for the resistor pins. Hold on a second. So the max that thing wanted me to push it was to 2.5 milliamps on the previous one. And if I go to 10K, then that's 24 volts would be putting it there. I guess if I go less than that, it would be pushing higher than that. Oh, man. So maybe a lot of these potentiometers wouldn't really work. What's the current allowable on this one? Oh. Resistance, yep, within 20%. Okay. So there's some stuff here that, oh man, that's gonna be hard. We might have to spend a lot of time tonight trying to find a part. I apologize for that, but this is how it goes sometimes. Because I don't know what the current maximum between A and B is. Ugh. All right, sorry. Well, let's see. It's never easy. TTL. Watts. Ooh. All right, either way, it looks like I don't think I'm going to be able to use this. I wonder what else I could use then. Or, let's back up. Interface, mounting type. Let's take that off. And our resistance. All right. What do we got on the high end of the things? This and this. What does this give us? These are probably real expensive, aren't they? Or just hard to use. You have to buy 77 of these. What is this, though? Plus or minus 15 volt operation, digital potentiometer. All right. So I don't wonder if what I want doesn't really exist. And I got to find something else. Let's see. Potentiometer. All right. All right, I'm trying to figure this out. Just give me a second. Interesting. So this article is talking about power supplies using exactly this, controlled potentiometers, but I don't know if they're really meaning to do what I'm trying to do here, which is higher voltage. This is doable somehow. Just not sure what I'm missing here. Cause mismatch problems. The range is reduced by doing this, but yeah. Doesn't really get me what I need though. This should be interesting. Let's look at this. Adafruit has a little thing on a board here that does this basically. using I2C. Tap points, even more interesting, we configure to adjust this resistance based on temperature with hysteresis to keep things from jumping around. The temperature compensation can be adjusted by using the lookup table. All right, what's the answer here? Oh, this other one they have is a linear. I would much prefer that. Analog voltage can be from 4.5 to 15.5. Ugh. So how is this done then? In high-end power supplies, like, evidently I can't find anything that goes to a high voltage range, so potentiometer 4 volts. Maybe I should just get an actual like knob potentiometer and then put a stepper motor on top of it to control it. That will definitely be the easiest way to solve this. Okay, here's an article from Maxim Integrated where they're doing something similar. Why VCC allows it to operate using a Zener diode to regulate its VCC supply. Changes. As VN is varied from 4.5 to 24 volts. So what is this particular chip? The DS3903. Doesn't look like it's sold anymore. Yep, not sold anymore. Alright. I apologize for how long this is taking. But it is hard to find something that does this. There's another part. VW. Okay. It looks like this doesn't exist. We might have to change the design somehow. But I'm not really sure how, or like, how far we can go there. This will handle up to 7 volts, so that's the max. Resistor terminals A, B, and W have no limitations on polarity with respect to each other. Oh, on polarity, that makes sense. Yeah, which one's positive, which one's negative. It just matters that you keep that within the VDD range. Ugh. 24-volt potentiometer. Really, any potentiometer would do this, I would think. Let's look at our categories again. Maybe there'll be something. Digital, slide, trimmer, rotary, potentiometers, and rheostats. What's a trimmer potentiometer? Oh. Well, if anyone has any ideas, I'm all ears because I am not finding anything. Yeah, it looks like this is the most like powerful or the strongest one. And I just don't think it's going to do the thing we need to. And it's $5 each, so. So standard potentiometers can do this just fine, though. So if we go find a rotary potentiometer, you know, a bunch of random things here. Is there like a max voltage? Doesn't look like it. But here, this is just a random 10K. Yeah, not much to it because it's going to be able to withstand just about anything. There's got to be a max current or something, though. Oh, 500 volts. Man. So how do we do this? The whole point of this thing was to have it programmable, but it looks like I can't have it go higher than like, I guess 12 volts. Oh man, I put so much effort into going towards 24 volts. I may not be able to though. I might have to just drop the entire system down to 12 volts. Well, it would make things cheaper and smaller. Oh, that's disappointing. All right. Well, I wonder, does anyone have any thoughts on this? Like, I desperately want to get it to 24 volts, but there just doesn't seem to be anything programmable that I can use to do that. Do we switch? You know what? How about a programmable regulator? Maybe that's a thing I can buy. Actually, let's see what I need. Let's see. Stock active. I didn't want to do this originally, but I may not have a choice here. So when that happens, just roll with it. These are expensive. These are all boost. Programmable with 3.3 or 5 volt output. Not really what I wanted. All right. Voltage output max. I want it to be a lot. 24. Output minimum. I guess I can pick all of these. 140 volts, geez. I want 1 volt or higher, but I think we'll just clear that. That'll probably be fine. Let's see what this gives us. Anything that I'm actually going to be able to use. Yeah, these are all like heavy duty heat sink parts. They're all expensive too. I mean, we're getting rid of our potentiometer here, and maybe some components on the regulator. I don't know. We'll have to redo all of those. Input max 26. Oh, I need the input max to be 28 or higher with our current setup. Yeah, so not doing ourselves any favors there. Oh. Well, anyone have any thoughts? Like, seriously, if anyone has any thoughts on this, like, I think there's not really anything we can do here other than changing our requirements. The thing we could possibly get are these, and this would be very hard for me to solder. This is an awesome little device. Requires a few components around the outside, but nothing crazy. I still don't get how this little chip can push 5 amps. Like, that to me is incredible. Oh, it has multiple pins going out. And a lot of pins coming in. That's how. I wouldn't be able to solder it myself, though. At least not hand solder. Man, I really need a hot air station. All right, I appreciate your all's time tonight. I might have to cut the stream short here. And I'll have to ask somebody tomorrow or something. Or Monday, see if I can figure out, ask somebody I know that knows about this stuff more than I do. See if I can figure out a solution. If there's a way to get, otherwise, okay, so if I can't get it, then we'll just have to drop it to 12 volts as the absolute max we can go. And let me find a digital potentiometer that can do that. All right, so in stock, active. Well, let's see if we can get a through hole part first. And what is our allowable range? 4.5 to 33. $4,300 available to order. $4 each. Oh, this is a minimum quantity one. Ugh. Oh. Okay, so not that one. Rochester minimum quantity for $95. Yeah, that ain't gonna do. All right, let's try this again. Through hole. Because none of those I wasn't really gonna be able to mount anyway. Jeez. I'm missing something that I was doing earlier because I was able to find something. I remember. All right, well, I'll have to look over the weekend then or something. All right, I apologize for cutting this off after only about, let's see, it looks like I've been going for like an hour and 20 minutes. That's it. But this is a pretty serious problem, and I hesitate to do other design choices because whatever this maximum is affects a lot of different things. And so Like, we can find parts everywhere else that can do 24 volts, but we'll be paying more if we end up not doing that. So if this doesn't work, I'll probably need a new transformer. Because if we drop down to 12 volts, there's no point in getting the 28 volt transformer. Like, it's too much. It would work, probably, but we'd have to, like, it's just more, we're spending more money than we need to. Those are fine. We're only getting one diode. Input AC would be fine still. Going with something smaller, we might be able to get more current out of it, though. So that'd be kind of cool. So we need that. We would need new regulators, because there's no point in paying for this one if we're going to be able to get something smaller. And then we got to find a potentiometer that can actually adjust that value and get all new components here. Alternatively, I'd like to just go ahead and do the 24 volts, but I guess we're not getting there. So if anyone comes across anything that could do it, some sort of digital controlled potentiometer that can handle 24 volts, that would be awesome. I just want to see the price of this regulator. Oh, these are like $1 each. I might get them anyway then, because at least it gives us some breathing room and they can handle the input. Okay. In that case, if we did that, if we just kept the same regulator, we'd probably have to adjust this resistor to be a lot bigger and then put the potentiometer up here. Okay. Fun. All right. Well, I appreciate you all for your time today, and hopefully we'll figure this out so that way I won't have to end early next time and stumble around in the dark like this. But thank you all for your help. I will see you later.